Welcome to another episode of my tutorial series on Amplify Serverless Stack, where we'll create an end-to-end application using AWS Amplify and AWS CDK TypeScript. Before we get started, I noticed that not a lot of you guys are subscribed to my channel, so if you do enjoy the content, consider to like and subscribe, maybe hit that bell button, it would really help me out a lot. And then let's go on to the agenda for this video. So the goal will be to deploy a Step Functions StateMachine and integrate it with our Appsync API that we created in the last episode. And before we do that, we need to make some changes to the storage and Cognito stack we deployed earlier. This does mean a couple things, but we'll get to that in a bit. After that's done, we're gonna deploy our step function stack, which we'll create and add some tests to it. And after that's done as well, we will integrate it to our Appsync stack so that we can start an execution of the state machine. And after that is done, we are expecting an order to be added in both the users table and the orders table. So that's the goal for this video. And before we get started, let's have a look at the diagram of the overview to what we have so far and what we will be creating. So if we look at the diagram, this is what we created in the last episodes. So we have Amplify frontend, and we have a Cognito user pool. When a user creates an account, the user pool creates, it triggers the post sign up Lambda, which will then create a directory in the images bucket. And this bucket will then later contain images related to the orders. So if you are not using images, you don't need that. But besides that, the post sign up trigger will also create an entry for the users table in DynamoDB. And for this, we will, for both cases, we will be using the sub, it's a unique ID for the user, to create the table and the bucket directory. Then we also deployed Appsync GraphQL, and the Appsync GraphQL currently has 3 operations, and one of them is to get the customer orders, but we don't have any orders in there, so that's not working yet. To delete a user, that's also not fully implemented, but last episode we did implement the payment intender. So it is partially working. You can send in the order and it will return the Stripe client secret, if I say it correctly. And what we're gonna extend on that in this episode is to add the step function. Step function will have a couple jobs. So it will have a submit job. It's a Lambda that will just submit the step function, its job. Then a status job where we will check if the payment intender has been completed. So we'll check the status, and if it is completed, we will finalize the job. And what that means is we will add the order to the users table under the user in the orders object. Then we'll also add a new entry in the orders object, orders table with a new order, with some details about the order and who ordered it and whatnot. And finally, it's not implemented yet, but I also added a DynamoDB table for stock, so I can keep track of the stock that I have in my inventory, and if something is out of stock, I can also order new things or say that it's not available. So what we will be doing in this video is mainly the step functions. We'll make a minor adjustment in the Appsync so that it can actually start the state machine. And like I said, I personally made some adjustments in the storage stack as well. So that's this part. But I will go through exactly what I changed. So if you were following along with me earlier, then know that it has been changed a little. And just to quickly say what I changed in the users table, I removed the sorting key. And the reason is that when you make an order, you can of course use a different email than the email that you signed up with. And if I have a sorting key there, I need to also add it inside of the step functions. So I decided I will remove it. So the user table only has a primary key, and the primary key is the account ID, so the sub in the Cognito. So with that out of the way, let's quickly have a look at what changed in the storage stack, and after that we can get started with our step functions. So I opened up my storage stack, and let's go to the changes that I made. And one thing that I do want to note, if you're gonna make these changes, you cannot just redeploy this this stack. It would actually mean that you have to delete all the stacks that we made before, as they are dependent, and storage stack is the first one that got deployed. It is quite a hassle, but you can just go to CloudFormation and delete all the stacks, and then make the adjustments if you want and redeploy them one by one. It takes about, I would say, half an hour, but let's go to the changes and then we'll have a look. So the change in the storage stack, the major change here was that first time we deployed this, we had only one table object, well, one table construct for DynamoDB. And as you can see, now I have two DynamoDB table constructs, and we have one table with sorting. And if you compare this to what we deployed the first time, you can see that there are practically no changes. It's exactly the same. Only thing that changed is the name, but the new one that where you can see table without sorting, well, it just does not have a sorting key, and that's the only change actually here. So if we go to the lib, we see that now I have an orders table, and that orders table does have a sorting key. And here I also add the secondary indexes. They also have sorting keys. And then I get to the users table, and the users table now does not have a sorting key, it only has a partition key. So this is important because in the step function I will be adding, well, I will be updating a field inside of the users table, and at that point I only have the user's account ID, which is the sub and the primary key here. And if I did not do it, I still need the sorting key, which I don't have at that point. That's why I'm removing it here. So also in the globally in the secondary global indexes, I'm also removing the sorting key, but I am keeping the email, so I could still search for a user with email. And another thing that I added is another table. It's with the sorting key, and that's for my stock. So if you do have stock and you want to keep track of it, for example, every time someone buys something, you want to deduce one of the inventories. That's what I want to do. Well, you can add another table. That's for me the stock table. So that's mostly the changes here. So if we have a look at the config, I also divided it up in 3 pieces. So we have the orders table, which will still have the partition key for order ID. And that order ID will be generated with UUID, which we will be doing. I think we already set that up. Then the sorting key will be the account ID, which we will also have at that point. And we have some secondary global indexes just for me to find it, because I will also make an application to process the orders as for internal use of the company, you could say. But next to that, we have the users object, and the users object will now have only primary key, which will be the account ID, and we'll have a secondary index, which will be the account email, and this will be set up when we create it with the post sign up trigger. And there we do have the account, so we can enter that. And finally, I also made a stock table, and here I have a product ID and a product name, and I also have a product name and a product ID as a sorting key. So that's what I will be deploying. So once again, if you want to make these changes, you have to destroy all the stacks that we deployed so far and redeploy it. And this is the first stack to deploy. So that means that you, after deploying this, you also have to make some changes in the AWS Cognito stack. So let's have a quick look there, what you would have to change if you would make these changes. So now I opened up the AWS Cognito stack, and inside of this stack you need to update two places. So first you need to update the config. You would have the KMS keys there. So the KMS keys are deployed in the storage stack. So meaning if you redeploy it, you also will create new KMS keys and you will have to update those in the config. So these are two keys. So it will be the table key and the bucket key, these two. And after updating that, there's another place that I made a change. So in the table, so in the post sign up Lambda function, in the table entry, I will use the account ID and I will also use the account email, and I will add an orders object that's an empty array. So we will be adding this, and the reason that I'm doing this, you also actually need this orders object for the Lambda step function. So that's why I made this change as well, as we will be appending all the orders to this object every time a new order has been made. So that's the changes in this stack, and we'll be redeploying this stack as well. And now that we made all the changes, we can start building our step functions Lambda. So let's switch over to that stack. So I created a new stack called AWS Step Functions, and then I ran the command CDK init language TypeScript, which gives us a start of our CDK stack. And now I'm going to install a couple dependencies that we'll need, and I will go through what I'm installing exactly. I also did add like 3 files here, so that you know it's the same files that I added at the start of the file and I add in each of my projects. So it's the ESLint ignore, ESLint tr, and the jest config that I like to have. So things that we will need. So what I'm adding is npm add types /AWS Lambda. I will also add AWS SDK client mock, and the mock is needed to mock the AWS SDK calls for the unit test that we'll be creating. Then I'm also adding CDK neg, and CDK neg just checks for security best practices. It's like security check. We used it before as well. And I will also add ESBuild, and ESBuild is used for compiling our node packages into our Lambda. And I will add these as dev dependencies. So let's install these. And once these are installed, we will install the next couple ones. And what I'm now installing is mostly just an ESLint. So if you are not using just an ESLint, you actually don't need to install this. This is just something I like to work with. Then we'll wait for that to complete. And then we will need a final couple dependencies. And these I'm actually also installing as dev dependencies. And now just some dependencies that we will need inside of the functions. So I will be adding add AWS SDK lib DynamoDB. So this is the higher API for the DynamoDB, it's the DynamoDB document. And I will be adding add AWS SDK client DynamoDB for the DynamoDB client. We will be adding the SDK for CloudWatch. And because I'm using Stripe, as I mentioned before, I will also be adding stripe. So that's stripe and add stripe/stripe.js. And I will be installing them, and let's wait a second. And while we're waiting on that to complete, also some things that I still need to add. So I'll make a new config file, and I'll also make a new types, and let's start populating them. So I will add all the types that we will need first, and we'll go through them in a second, but I'll also add the config. So let's go through what we will be putting in our config. So the properties for our stack, the AWS Step Functions Stack props, will extend the stack props that we get from CDK. And what do we need? We need KMS key ARN for the orders table. We need one for the users table. We need some properties for the submit job and the status job and the finalized job. So these will all be lambdas and jobs inside of our state machine. So next, we have some inputs here, and I will go through them later when we get to them. I just put them here already, but when we reach it, I will go through each of these. So for now, it's not important to look at them. Then let's look in at the config. So as I mentioned, there's some things that we need. In the props, each of the props will be put in the environment variables of the Lambda. So each of these will be available inside of the Lambda in the environment variables. And what are we putting in there? Well, the entry is the location for the code that we will be adding here for this Lambda function. And as I said, props are just environment variables. And we need wait seconds for the submit job. We need the stripe key for the status job, where we will be checking the stripe status. And in the finalized job, we will need 3 of the DynamoDB table names so that we can make updates to those tables. Okay, now that we have that, let me get this. And here make the changes that we are expecting these props. Okay, let's have a look. Okay, we have the changes here. Let's load in the stack props from the config. And because we are also using the CDK neg, I'm gonna also import the CDK neg AWS solutions check. And how do we use that? Well, it's really simple. We will say CDK aspect of app, which is our CDK app, and we will add the AWS solution checks, which will actually check our CDK stack when we compile the CloudFormation template, and it will check the CloudFormation template. So that's all what we need here. The config should be good as well, and note for yourself, these are dummies, so you do need to look into your account and get the KMS keys there. Same goes for the stripe key, of course. Then here we will need a couple services to make the state machine, and our services will mainly be lambdas. So let's make 2 new folders. Lambda and step functions, of course. Step functions. Then we will have a Lambda function, and so we will have a couple things in the step function, in the state machine, and the state machine's components will be stored in the step functions, as Lambda will just hold the Lambda code. So we created the Lambda before, it won't be much difference, but in the step functions, I will add some tasks and we will go through them later. So first, let's look at the Lambda function. So it's not really any different from the Lambdas that we made before. It's again a Node.js function. It will expect an entry and some environment variables, and we will also allow it to put metrics into the CloudFormation metrics. As later on in the series, we will also make a dashboard with CloudWatch, and then we can see all the things that are happening with our system. For now, we're just giving the permissions, and in the Lambda function, we will actually add the metric as well. And you can see them in the console, but later on, we will create a dashboard for that as well. So we have a Lambda function, and we have some jobs. And let's go through the jobs that we have and what they are used for. So in the step functions, we have a definition, and the definition is like the final product, but let's go through what the definition holds. In the definition, we are telling what our state machine's structure will look like. So in this case, let's just go through it. We were expecting a submit task, which is a Lambda invoke. So it will be a Lambda that submits the task. It's the first thing. After that Lambda has been invoked, the next step, so as you can see, .next, will be wait time, and we'll get to wait time, but that's a special step functions function to wait a couple seconds or minutes, and we'll get to it when we're there. After waiting, we want to execute the status task, which will be another Lambda that gets invoked. And if that Lambda has been successfully run, we will check with the step functions choice if this job has been completed. And how do we know if it is completed or not? Well, we will look inside of the object that the status task gives us, and if the status task gives us an object with the key status and the value cancelled, we will execute failed job, which is also a special step functions function, which we will get to later as well. Or if the status key has the value succeeded, we will run the final Lambda, which is the finalized task, and the finalized task will do the updates in DynamoDB. And if we have neither of these outcomes, so we don't have cancelled and we don't have succeeded, for example, it's still processing, then we will go back to the wait time, and after wait time it will again go to checking the status, and then everything will be looping until it either fails or it runs out of time. And well, I'm expecting like half an hour, something like that, in the total time that it will run. So that's why I'm also using normal step functions. If you are using step functions that only have a max lifetime of 5 minutes, then you can also use express functions. But then you cannot use some of the special operators, as maybe I will be replacing the finalized task with direct operations to update the DynamoDB tables, but I'm not sure about that yet. So for now, let's just use Lambda. So that's the definition. Definition, once again, it will show which steps will be taken in which order, and if there's a wait time and all other things, you have to put it in your definition. So I will go to the console in a bit, and then you can also see the definition as a schema, as a diagram. That's very nice to see actually, but we'll get there. So the definition is what you have wrote. Then a field job is actually really simple. As I said, it's a special function from this AWS Step Functions, and well, all we do is return a new job is the new step functions field, which will need this, which is the scope, this, which is in this case stack. Field job is the construct name. You give a cause and the error. The cause can of course be different than the error, and you could take it also out of the object. For now, I just say that it's filled, and that's all I need for now. Then let's have a look at wait time, also a special function. So in the wait time, as I said, so also from step functions, we create a new step functions wait. We add the scope, and I'm calling this the construct. I'm calling wait x seconds because I'm gonna wait x seconds before I go to the next function. And here the time that we're waiting will be taken from the second path in wait seconds. So what that means is we're expecting in the object, we're expecting a key with wait seconds as the value, or as the name, with the value, and that value will be the amount of seconds that we are waiting. And the reason why I'm putting it like this is because I will be incrementing it each time that we run the loop, but we don't find it. We will increment it with 2.5 minutes. So we will be waiting some more and some more and some more until we don't wait anymore and we say the job is filled. So besides that, we also have some tasks. And in the tasks, I will go through it a bit more in depth, just so you can get a clear understanding of what this is. So in the tasks, we are using the Lambda functions. And the Lambda functions, normally you just return a string or something with the Lambda. But now what we are returning in the Lambda will also be returned to the Step Functions StateMachine. And inside of that return value, there's a field called payload, and the payload will be populated with the outcome of your Lambda. So when I get a new event, this event will be processed, and then my step function will have an output, and so the output of my step function in full, so not the Lambda, but the step function, will be an object which contains some details about the state and the runtime and everything, but it will also contain a key named payload, and the payload will contain the output of your Lambda function. And I only want to pass that part of the object to the next function. So when I call the next Lambda, I only want to give the part that's inside of the key payload, because I actually don't need the rest. So that's also what you're seeing here. I have Lambda function, which is the Lambda function that I want to run when this task gets triggered. And then in the output path, I am adding this. So it's a $.payload with capital P. And so this only means that I only want the output of the Lambda to be passed to the next Lambda. So if I would have like an object, and inside of that object I was returning result, then it would mean that I need to put payload.result, and then I would only give the value of the result. So do note that. And if I remove payload, it will give me the total result, which means I would have both the output of the Lambda, but that would be inside of the key payload in an object which is the output of this task. So with that said, it's not much code, but it is a bit complicated. So that's what I'm doing here. So the tasks will be Lambda functions, and they will return only what the Lambda is outputting onto the next step function. So with that said, last thing that we need is the state machine itself. And the state machine will be a new step function state machine. It has a construct name. It has, of course, the scope. It has a name. Well, in my case, it's called PH payment processing. You have a definition body, and the definition body is, like I said before, is this definition here. So it is a description of which steps will be taken in order and in which order. So that's what we are passing to the state machine in the definition body, and that's a step function definition body dot from chainable, and then we add the definition there. The timeout, as I said, the normal state machine can have a timeout. I don't know exactly from the top of my head how long, but it can be very long. But if you have a very short step function, you only want to check something within 5 minutes, then maybe the express step state machine is also something for you, which is a bit faster than this one. But as I am using 30 minutes, I will not be able to use that. And we also have a comment, and you can add any comment there, but you can also add later some name or some details to the start of the state machine. But these are all the constructs that we need. If we have all these constructs, we are able to create our step function. So let's go to the main file. And then I'm also gonna import a couple things. First, let's import all the constructs. Oh. Okay, so these are all the constructs that we just walked through, and I'm also getting the next expressions, and also mentioned that. But what do we need to do? First, we will import a couple things. So everything that we've already created, we will start with those imports. And I also need to have the dependencies, of course. So first, we will get KMS key for the orders table, KMS key for the users table. We will get the orders table, and we will get the users table, and we will get the stock table if you have it. And why do we get these? We get these because we need to give the Lambda functions permissions to access them, or else they will not be able to make the changes into our table. So now that we have that, we're gonna create 3 Lambda functions. And the 3 Lambda functions that we were creating, I'll be naming them submit, status, and finalize job. Submit won't do much actually, it will just be called and it will add the wait time to it, and then just start waiting and then check the status job. The status job will get an event. It will check the payment intender if it has been successful. If it's been successful, it will also get the email entered in the payment. Then it will give all of that onto the next job, and finalize will then add an order in the orders table. It will add an entry in the orders object of the user, and which not implemented yet, but it will also later deduct something out of the stocks table. That's why I have it here, but not implemented yet. So now that we have those, like I said, we need to grant the permissions for them to actually adjust the tables. So which permissions am I giving? I'm giving grant, encrypt, decrypt for the orders key and the users key for the finalized job. And I'm also granting the users table grant write and the orders table grant write and the stock table grant write. So those are the permissions that we will need. Then I will make all of the jobs and tasks that we will be using in our step function. So like I said, we have a wait time. This is just the job that we have that I walked through. So that's the wait job here. We have a failed job, which we will run if we get cancelled in the status. We will have a submit job, which will just submit the task and add the wait time to it for the first time before we start incrementing it. We will have a status job, which will check the status of the stripe and the finalized job. Okay. And now we will use the definition that we created. So the definition will just contain all of these tasks. So these are all these tasks. Now that we have a definition, we will create a state machine. So state machine is very easy. We just need the scope and we need the definition. Optionally, you can add an extra field for the name so that you can easily create a name. I just didn't do that here because I didn't need it. But you can do it to make it more reusable. And with that, we actually have our step functions for the infrastructure part done. I am gonna add some next suppressions. So I'm adding a couple next suppressions. I'm adding the AWS solution IAM4 because I am giving the role for the Lambdas permission to write to all of the CloudWatch metrics, and which I will be restricting later, but as I probably will be changing the names often, I just give them to all of the metrics. They can do put metric. Then we also have some wildcard permissions for the AWS solution IAM5 because we are granting the read-write encryption, grant encryption and grant encrypt and decrypt. Sorry, I was freezing. So that's also something that is not the best practice, as you could narrow it down to only a certain key and with only certain activities, but I am for now skipping that. I'm also just doing, I'm not doing all, and I'm not doing X-ray. And X-ray, you can put X-ray, it's really nice. You can see exactly what's going on, how much milliseconds everything took. But I will be adding that probably later. For now, I just don't, I was not bothered to just leave it out. So that is the infrastructure of our stack. And what do we need after we have the infrastructure? We need some code for our Lambda functions. So I will be adding another folder called source. And here I will add a couple folders as well. CloudWatch. And I will add finalize. And submit and status. So 4 folders, we have CloudWatch, finalize, status, and submit. And CloudWatch just contains the CloudWatch. So let's go through what in CloudWatch, what will be in CloudWatch. So CloudWatch will just contain the CloudWatch event, so that we can use it throughout all 3 of the functions if needed. But I just separated it from the other stack so that I don't need to reduplicate the code. But what are we doing here? We did this before as well in the post signup function. So what are we doing? We're gonna do the put metric data command, and here we will add a metric name, the unit, a value, the time when the metric was created. I will be adding the payment intender ID here so that if something fails I can always look it up, and we will add the metric name. And it's all variable so that we can use different metric names depending on where in the process it fills, and the namespace in which we can find these metrics, which for me is print helix. So that's all for CloudWatch. Not so much actually, but so that we can reuse it. So then let's go to the submit. As I said before, submit doesn't do so much at this point. It's a Lambda function with the handler. It will receive a iSubmit event. So let's go to iSubmit event. So for the submit event, we are expecting an event which will contain a payment ID. So that's the Stripe payment intender ID. It will contain an user key, which is a boolean indicating if we have a logged in user or we have an IAM user. It will contain identity. An identity will be either the sub of the user or it will just be anonymous. So if we don't have a user, it's an IAM user, this string will be anonymous. Well, the value will contain an anonymous. Then we will have a validated price. So that's the price for the products that we are sending. And it will contain an array with products. And we've seen products also in the last episode. So products can be different for you, but for me, if we look at it, it contains an ID, it contains a price, quantity, a color, a size, and some things for me. And these will later be the keys for the S3 objects. Currently, there will just be the location of the pictures, but later they will be the keys of the S3 bucket where I stored the objects. So that is the submit. And so we are deconstructing it from the event. We are extracting all of these. We are adding 2 extra fields in the return value. So the retries will be set to 0, which will come back later in the next piece. And we will add wait seconds. And as I said, we are checking inside of the object for a field called wait seconds. And that's the time that we will wait. And here we are getting those seconds from the environment variables. And when you get them from the environment variables, it will be a string. And I do want to use a number as the value that we're expecting is a number. So I'm converting it to a number. Just note that environment variables are strings. So I put it like this. And this means that the output of this Lambda, which is this, will contain the values that we need, but it will be inside of the object, inside of a key called payload. And that's again why we are passing, let's go back to the task. That's why we're passing the $.payload. So this object will be this object. Okay, so if we want to go to payload.user, that will be this, payload.identity, and so on. So that is how it works. And if I do all, I will get this object and some more data on the state machine itself. So that's the submit task. Now let's go to the status. And in the status task, a lot more is going on. So let's go through there little by little. So I'm importing Stripe, I'm importing CloudWatch, and I'm importing the CloudWatch handler that I created here. I'm also getting the iStatus event. So let's go to iStatus event. What does it contain? Well, it pretty much contains all of these things here, but it will contain some extra values, as you can see. So it has retries and it has the wait seconds. And these are the two that we added in the submit function. So we are expecting them here as well. Then let's go back. So we are also creating, for lazy loading, we are creating the holders for the Stripe client and also for the CloudWatch client. And then at start, inside of the try catch, just so if something goes wrong, we can see what's going wrong. Inside of the try catch, we are lazy loading the clients for both Stripe and CloudWatch. And after we have done that, we deconstruct all of the values out of the event. And here, so that's where retries come in. Pardon me. If retries now is more than 3, so let's say retries is 4, we're gonna say status cancelled, and the job will go into filled job state. And we will also create a metric saying cancelled payment status metric. I might change this name to max retries or something, but there we add the client and we will add the payment intender ID. And that's also what we were expecting here for the props. So that's the first time that we use it. We also use it in finalize task as well. That's why this is separate. So that is if we have the max retries. If we don't have the max retries, we will increment the retries. Then we will increment the wait time as well with the retries times 150, and 150 is 2.5 minutes. So we are incrementing first time for 2.5 minutes, then for 5 minutes, 7.5 minutes, 10 minutes, which is 25 minutes total. And we are waiting the first time as well for 150 seconds, which is also 2.5 minutes, so 27.5 minutes in total that the state machine will be running. And it is max timeout at 30 minutes, so that is within the time span, I think. So after we increment both the retries and the wait time in seconds, we will get from the payment intender from Stripe. So we use the Stripe client. We say payment intents.retrieve, and we enter the payment ID. And the payment ID, like I said, that's the payment intender ID that I create inside of the, well, we will get there in the Appsync, but in the Appsync, in last episode, we were creating a payment ID, and that payment intent has the ID that we are passing into the state machine. So from there, we're getting the status, and the status can be a couple things. So if I like to see, status has a couple of results, can be cancelled, processing, requires actions, and blah blah blah, but we want succeeded. So then we have some placeholders for the shipping object, which can be found in the payment intent, the payment method, which is an ID in this case, which also can be found in there, and the receipt email. And the receipt email is just the email of the payment entered there. And it is not inside of the payment intent, but inside of the payment method. So that's why these are all placeholders. So once we have the status succeeded, so we know that the payment has been done in this case, we will get the shipping, as you do need to fill in the shipping before you can succeed. So we'll get the shipping object, which contains the address of the user and sometimes the name and phone number as well. So then we will get the payment method, which is an ID, which you can use to get the payment itself with some extra details from Stripe, which is what we're doing in the next line. So we're saying await Stripe payment methods dot retrieve payment method as string, as this can also be null or something as an object. From that, we are retrieving the well, the payment method itself, and in there we have billing details.email, which is the email entered in payment, and I will also demo that in a bit when we have everything deployed, but it will contain the email that the user entered when making the payment. So this will also work for people that did not log in. So IAM user, which is actually making a payment at the end, he will also enter an email, and so in this way I can get the email for both the user that's logged in and the user that is not logged in. So that's why I'm using the payment method from Stripe to get the email instead of passing it through from the front end, as if there is no email in the front end, I will still have an email at the end of the payment if you are an anonymous user. So we only do this if we have status succeeded, and we will also return some more than, of course, only those things. So what will be in the return statement? A couple things. We will return the payment ID again. We will return the user, which is a boolean if it's a user or an IAM user. We will return the identity, which will either be the substring or a string saying anonymous. The email for both anonymous users and non-anonymous users. We will get the shipping object, which is the address and the name and the phone number. The validated price, we will get the result, which is the status itself. Let's hope it succeeded. The products, the number of retries, and the wait seconds. And the reason why we are giving these back is that if we have, for example, processing, we want to wait again. We want to increase also the wait time and also the retries, so that when it gets back here and it has been more than 3 times, it will just be cancelled. So then I create a matrix for for all of the outputs. So I just divided it in 3 steps. I say succeeded, processing, or cancelled. With cancelled, it will just stop and the state machine will go into filled job. Processing, which is neither cancelled or succeeded, will go back to the wait time with the incremented wait time and incremented retry count. And succeeded will finalize and go to the next step. So we have this matrix, which each of the outcomes are each of these functions, which just enters this string as the result. So this just either succeeded, processing, or cancelled. And these are all the options that you can get for status from the request that we're making here. Then once we have the matrix, we only need to return the value as we got. So what I'm doing is status matrix. I'm adding the status that I retrieve from Stripe here. And depending on the status that I got back, I am returning an object, but it will always be an object like this. So the object in this case for payload will be this object, and depending on if it succeeded, we will populate a couple extra of them. And if it's not succeeded or we have an error, we will console log the error. I was thinking of maybe adding it to DLQ or maybe something else. I'm still looking into that, what exactly is the easiest way for me. But we will add another CloudWatch event, which is a failed status metric. So that this is a cancelled payment status at this point, and this is a failed payment status metric. So if something fails, I can also see it in the dashboard, and we can also create some alarms, but that will be for another time. But it returns the status cancelled as well, which will cause the state function to exit the job in this case. So it will not keep endlessly retrying it. Now that we have that as well, the only thing remaining is the finalize function, So let me close a couple of these up. So in the finalize one, I will go through it as well. So we are importing there a couple things. So we're from the DynamoDB client, we're of course getting the DynamoDB client, and then from the from the lib Dynamo, we're getting all of the commands and the DynamoDB document client, which is a higher level API that we can use. And why am I using this? If we are not using this, we have to marshal each of our inputs. So for each value, we have to say if it's a string or a number, or so it's a kind of a different format than you would usually use. And with using the document DynamoDB document client, we can just pass in a JSON, and we can use that JSON to add a new entry in the DynamoDB table. So that's why we are using both the client for DynamoDB, and we are using lib DynamoDB and getting the DynamoDB document client. So we're also getting the CloudWatch client. We're getting UUID, as we will be creating order ID in this function. We will use a put order command and an update order command, which I will get to later, which are both DynamoDB commands. The handle CloudWatch event, which I already showed before, which is just for adding a CloudWatch event, and then the finalize event. Let's first look at that. What are we expecting and what is in it? So in the final job, we're expecting a couple things. Well, I'm expecting a couple things, might be different for you. So I'm expecting the payment ID again. I'm expecting a boolean to see if there's a logged in user or not. I'm expecting an identity, which is either the sub or a string, which is anonymous. An email. I'm also expecting an object for the payment intent shipping, which contains the address, name, and phone number. I'm expecting the price, and I'm also expecting some products that have been bought in this order. So that's what should be coming in as an event. And again, everything is in a try-catch block, and we can look what is an error. So just to check if you have an error and you don't know what's going on, it's really handy to catch your error and just log it out. And you can see this in CloudWatch. So what do we need here? And as I said, we are using DynamoDB document client. Man, I always have to think it twice when saying that. So we're not just using the DynamoDB client, we're using the DynamoDB document client. And once again, the reason for this is so that we can just use JSON objects. And we're also lazy loading the CloudWatch client. And again, lazy loading, if this Lambda gets triggered multiple times in a row, we don't need to recreate the client if it's already created. So that's what that does. Then we also initiate UUID, and UUID will return a string. So this is just a unique string created by UUID. Then we deconstruct the event objects. So as I said, we're expecting a couple values there. Then we will create a new order date. So new date to ISO string, and that will be the order date of now, which I will put in. So then the put order object and the update account command. So what are these commands doing? The put order command will return a command for the put order in DynamoDB. And let's go to it just to see what's going on. And first, let's look at the inputs. So what are we needing to create a new entry in the orders object, in the orders table? Well, we will need a payment ID. We will need an order ID. We will need a price, an order date, the identity of the user, or if it's anonymous, the email, the shipping object, and we will need the products that have been bought. So let's go back here. So we're getting put command input from the libdynamo, so not from the DynamoDB client, but from libdynamo as we're using the other client. And then we can just create a new object. As you can see, this is just JSON object. And JSON object contains a couple of values. So it contains the order ID, the account ID, the email, payment ID, price, order date, shipment date, order status, products, and shipment. And I do want to note, I don't know the shipment date yet. That's why I'm putting in pending. You cannot put an empty string in here. So because these are global indexes that you can search on, they need to have a value. So for now, I put just pending. So don't put an empty string here because it will not work if you wanna add a new entry to the table, because they are global indexes, so they need to be filled in. But table name I'm getting from the environment variables, so we will be adding them there. As you could see, we are adding 3 table names, and these are all the table names that I created. So if your table names are different, add different table names there. But inside of the function, so this is just one entry. So the entry inside of the table that we're expecting to see after this has been run is just one new entry with an order ID as a primary key, and it will have some extra values so we can search on it. So let's go back. So that's the put order command. And so like I said, it only returns the put order command, but you always, you still need to use the client to send it. And after it's sent, I will log the outcome. And you can of course check if it's successful or not, but well, if it fails, it will be caught. But if it returns, for example, still returns something, but it doesn't throw an error, there should, you can add some more validation here. So it's not perfect yet. But that's it for the orders table. But now that we have put in the orders table, we also want to add these orders to the account of the user. But if there is no user, we don't need to do this. So if you are an IAM user, we don't need to add this to your account because you don't have an account. But if there is a user, so that's where the boolean comes in. If there is a user, we're expecting that the user sub should be in the identity. So that's why we are passing it here. Then we have a payment ID, we have an order ID, we have a price, an order date, the sub, and the products. So let's go there. And here I just went through these exact values. So the put command does need these. And let's go. So the update command. Sorry, I was talking about the update command. It's pretty much the same, but the update command needs these values. And then it is a bit different than the command that we just did, as the put command just puts in an object, and the update command will update a value inside of the DynamoDB table of the user. So what do we need there? The update command input takes again a table name, which is the customers table in this case, to also expect the key. And in our case, the key is only the account ID. And as I said, I changed my storage stack because it would also need a sorting key if it had one in the table. But for now, I'll just use only an account ID, and that should be inside of the identity. So the identity is the sub of the user, if there is a user. So that's what I will be searching on. And for that user, the expression that I want to execute is set orders, which is an object inside of the entry. I want to append, because it is a list. So I will do list append the orders object with a new orders object. Well, the orders list with an order object. And in the expression attributes, we define what this order object is. So in my case, order object is an array with an object, and that object contains an order ID, which is the UUID that we created, price, an order date, again shipment date set to pending because we cannot put an empty string. You can also put the date in there, but for now I'm putting in pending. It will have the order status, and it will have a product, and you can add some extra keys here as well, but for now I'm just adding these. I might automate also the tracking, so it might add in the future a tracking ID, so you can also keep track of your track and trace parcel. So now that we went through the finalize as well, I would say that we now have, pardon me, we have both the infrastructure done in lib, and we also have all the Lambda code that we need. So those are all the Lambdas. Then I'm also gonna add some unit tests for testing both the Lambda codes and testing the infrastructure. So let's start with some unit testing for now. Okay, let's start with adding the test to our stack, and we will add a couple tests to our stack. So we will add a test that will test our CDK infrastructure. So here, let's replace that. So let's go through what we are doing. So from AWS, we are getting the CDK lib, we're getting template from assertions, then we're getting the stack, and we're getting our stack props. We're loading them in here, and we get the template. So in the template, it's like our CloudFormation template. We're expecting a couple properties. So we expect the Lambda functions to be created. So in the template, we will say has resource property AWS Lambda function with this name, submit job, status job, and finalize job, and the timeout and the runtime that we gave it. So if all three are in the template, this test will succeed. If it's either the timeout is different or I don't know, the name does not match up, then it would fail. That's the first test. And you can add more tests, of course, but it's really simple to show what you can do. You can do as much as you want. Then we're also expecting a new state machine to be in the template, and the state machine name will be the name that we gave it, and mine was PH payment processing. This will test our infrastructure, so that's for lib. And then we also will add another test here, and that's the CDK neg test. And what the CDK neg does, instead of every time running the test with CDK synth, you can just with npm run test, it will also test that, and it will expect that there are no suppressed warnings or no suppressed errors. So if you do have any errors, this test will also fail. And the final one that we will be adding is for the source, for the lambdas. And I thought it would be interesting just to go through a couple of these, because there are some tests that are quite interesting, just to have a look. So if you don't know how to mock either the clients for the AWS services, or you don't know how to mock the Stripe, well, Stripe, I won't do anything really fancy, but I will show you how to unit test both of the functions that we are using. So first, we start with importing the handlers. After importing the handlers, because all of them are called handler, I am importing them a little bit differently named. So 3 of the handlers for the submit, for the status and finalize handler. Then I'm importing the mock client from AWS SDK client mock, and with this I'm able to mock each of the AWS services. So that was the reason why we installed this at the start. Then I'm gonna import each of the clients that we are using inside of our Lambdas. So that's the DynamoDB client, but also the DynamoDB document client, the CloudWatch client, and I have some events here. I will go through them in a bit as well. But with the mock client, I input the clients from the AWS services that I'm expecting, and that will just mock those clients for us. So nothing really fancy. It's really simple out of the box. You get the mock client for the SDKs. You put the SDK client inside of the mock client, and we have our mock client for DynamoDB. We have our mock client for DynamoDB document, and we have our mock client for CloudWatch. And do note, you do really need to mock both of them, because we are putting them both in the code. So mock both of them, even if you're only using DynamoDB document client, because you do need the DynamoDB client to instantiate this one. So these are all the AWS services mocked, so we can use them. I will also show it later how to use them. Then for the Stripe, we are using two methods. We are using the payment intents retrieve and the payment methods retrieve. So two just functions that we can mock, because we can now mock the return value for these functions, and we put them in here. And because it's a module, we do need to add this here. Yes, module true. And now mock will, if we are running the unit test, Stripe will be mocked and it will return this. So now we can, by mocking these return values, we can also return what we want inside of the test. Then we are not done yet, because we also have the UUID, and if the UUID changes each run, each time the test would fail. So we're also mocking the return value for the UUID, and I just generated one UUID and then I put it in there. So now every time we're expecting that it will be this UUID. And then let's go to the test itself. So that was all the mockings. Now let's go to the test. And before we go to the test, actually, we do need to do something. So because also we are creating date.now.isostring, so we do need to mock that as well. So just spy on date prototype to isostring. So what we're doing is we're gonna replace the date protocol, the function to isostring, with the mock implementation that will return a mock time. So that's also something that we're doing. And then the before each will be run before each test is run. So we will also add the environment variables there. So that's also something we need, as we are putting them and expecting them inside of the code. When mocking these, we have to add mock data for them as well. So after each test is run, we're gonna restore each of the mocks. So we're restoring each of the AWS clients, the payment intenders, and also the time. Then finally we get to the test, and the tests are divided into three pieces. So we have the submit functions, the status, and the finalize. And in the submit, it's nothing really fancy going on. We get an event, and then we expect a result, and the result has to contain the retries and the wait seconds this time. Nothing much can go wrong there, so that's all we need. Then in status comes a bit more interesting. So in status, we're gonna run a test for each of the possible outcomes. So for succeeded, processing, and so on. Then we also expect the state for the status key, which will be here. And then in some cases, we expect email, and in some cases, we expect nothing. And if it succeeded, we also expect shipping to have an object. And I didn't populate it in this case, but you can populate it as well. So I'm gonna map through this array, And for each of them, I'm gonna create a new test. And then I'm gonna mock both the payment intender and also the payment method by doing mock to resolve value once, and then what the return value would be in that case, and then expect also the same input, but with a slight adjustment for the ones that are returning shipping and the ones that are returning email. So this will only check for each of these processes. Then in the next one, we are checking if the max retries has been reached. So it's 4. Then we're expecting a put metric command to be executed. So this is how we are mocking that one. Because we're saying resolves, it will return this object. If you really want to return a certain object, for example, you want to check the status code or something, you can also put it in there. And if you do rejects, it will fail to add the metric. So this is how you control the return value for the SDK clients. And here you can see an example of that. So here we're gonna fail the payment intent mock. It's gonna mock rejected value once. We are not returning any value in it, but you can return you can put a return value in there. Then we are expecting that the put metric data command will be called, as this is a failed attempt. So we're gonna resolve that, and we're expecting a status to be returned with cancel. And finally, we have finalize tests, and here we are mocking the DynamoDB client. So for both the DynamoDB client put command and the update command, we just resolve an empty object. So you can return something, but just as the previous one, because we are not doing anything with the output of that command, I'm not putting anything in there. So we just say that it will successfully resolve it. Then we will wait for the handler to handle the event. This is some function that creates the event. And so in the previous ones, we just checked if the value was okay, but here we're gonna go a little bit more in depth. So let's go through it. So first we're gonna make a constant called put calls, and put calls is an array of all the calls that were done inside of this test, which had the put command identifier. So we're gonna expect, because this time we are only running it once, I'm saying put calls to have length 1. So we're expecting an array with 1 object in it. Then we're gonna get inside of that array the first object. It contains a key arguments, which is also an array, and in there there's the inputs, which is which I will be using as put command input type. So why am I doing this? So then it will recognize that there's a field in there called table name, and I'm checking for the first call of the put command if the table name equals the test table name that I added here, and that is the one that I entered here. So you can do that for each call. You can also do it for the update command, as you see here. Here I am checking all the update commands, also expecting it to have the length of 1. Then I get the input of that, and here I check a couple more values. I check the table name, I'm checking the key that I'm expecting there, so the sub of the user, the update expression that I'm using, and the expression attributes. Just so this is the value of the orders that I'm gonna add, as you saw in the code. So this way you can check each of the values, and this is just for this command, but as you can see, you can do this for each of the SDK calls. So if you're using a different SDK, this can also be used for the CloudWatch SDK to check what kind of metric you are sending. You can look inside of the calls and how many calls there was made. So that's an easy way to check and test SDK with unit test and jest in TypeScript. Then in the final one, we're gonna reject both the put command and the update command, and we're gonna resolve the CloudWatch command. And so what are we expecting if the DynamoDB commands fail? It will send the CloudWatch command. So, and in which order does it do it? It will first try to do a put command to put an order, then it will attempt to update, and if that also fails, then it will, well, if the first one fails, it will already put a metric, and if both of them fail, it will still put out the metric. So in this case, both of them gonna fail. So I'm expecting the put call to have a length of 1, and then the update call will not have any objects because it will fail at the first one and immediately try to send the metric. So in the metrics one, I do expect 1 to be present. So that is the unit test for the Lambda functions. Now that we also have that, okay. Okay, then I have both of the tests, the code, and also the infrastructure done. Then we can deploy this, and after deploying it, we still have to adjust some of the code inside of the Appsync, as we will initiate this from inside of the Lambda of the payment intender resolver, and we need to add some permissions as well. So you can deploy this. After deploying it, let's check what we have in the console and then move on to the adjustments in Appsync. After deploying our stack, you should be able to see inside of the step functions inside of the console that your state function has been deployed. I already ran mine twice, so if you were not seeing anything here, that's not anything wrong. But if we go to the step functions and then go to definition, so the definition that we were talking about earlier. So if we have a look, so this is the definition that we created. After deployment, you should see something similar to this. And what we're seeing is that the state function will start. It will start with the submit job task, then it will wait X seconds, and then it will check with the status job task what the status is, and then if the job is complete, we will go to finalize job task. If the job has been cancelled, we will go to failed job, and eventually, of course, in both cases, we will go to end. If it is anything else, for example, it is processing, it should go back to wait X seconds, and here wait X seconds has been incremented, so it will wait a couple more seconds, and retries has also been incremented. Then it will come back to the submit job. Here it will again check if the values are not exceeding the max retries, and it will wait for a couple, well, after waiting, of course, it will again check for the status and so on until it either goes to the finalized job or it will go to failed job because either it had too many retries or the status was just cancelled because someone didn't want to continue with the purchase. So this is the state machine. And currently the state machine is just loose from the rest of our stacks. So now we're going to integrate it into our Appsync API so that whenever someone calls the payment intender and the payment intender has been created, the step function will be started and it will check for the next half hour if the payment has been completed. And if it has been completed, it will add it to our DynamoDB table and the users table. And eventually it will also deduct it from the stock inventory, but that's not implemented yet. So let's go to the Appsync stack and make some adjustments there so that it will initiate our state machine. I opened up the Appsync stack that we created in the last episode. And we're gonna add some changes here so that it can actually start the state function that we created. The first thing we need to do is import the dependency of the step functions. So we're gonna import it as SFN, and we just deployed it, but you also need the ARN. So I'm gonna make payment intent state machine, which will be SFN state machine, and I will get it from the state machine ARN, and that state machine ARN I will of course add it here. Which is a string. I will add it here as well. Which is an ARN. So you can get this ARN from the console where we just were. Should have it in the upper part. And after we add it, we have the state machine here. And why do we need it? Because, well, this Lambda that we have here, payment resolver, that needs to execute the state machine. And in able to execute it, we actually need to grant it that permission. So we're gonna say the payment intent state machine that we got from the ARN. We're gonna grant the start execution permissions, and we're gonna grant them for the payment resolver. So this is the Lambda that gets triggered, and it will be able to start the execution of the state machine. If you don't have this permission, then this Lambda won't be able to start that state machine, so you really need to add it. So after you add it, we can go to the code. So there we had the resolver, and that's the payment intender handler. And here we need to add a couple things so that it will be able to start the state function. So first, a couple imports. So from, of course, we need to also install it. npm install, and then add AWS-SDK/client-SFN. So let's install that. And from there we are getting the client, the start execution command, and the start execution command input. And we're gonna also add the step function client here so that we can lazy load that. So let's do that here. And we're making a new client with new SFN client. You don't need to put the input unless it's in a different region, then you can put your region here. So we're logging the event, we'll remove that eventually. And here we will need to add the event so that it starts step function. And for a step function, you can actually only pass through a string. So what I'm gonna do here, some functions that I'm not using here in the demo. So let's see. So just for my convenience, I would just use only the Cognito sub for now. So I'm expecting that the identity in this case is AWS Cognito identity, and it's not the IAM identity. So later on we will also add, of course, the IAM access, and in that case we will not have a user and we will not have a sub. So in that case we need to do something else there, but that will be for a later video. So the validation event, so the payment intender, that will be validated will contain a couple things. So from the payment intent that we're creating, we will get the ID. In this case, like I said, we will put in a user, but later on we will differentiate if it's an IAM user or a Cognito user. And the identity will contain either the sub or it will contain a string anonymous. We need the price and we need the products that we want to add. So this will be created into a string, and that string we can then use in our input command. So for the start execution input command, we need two things. We need the ARN of the state machine. So that's why we added it to the project. And we will be needing to add it also at environment variables of that function. Then we will also input the validation event. So the things that we want to submit to the submit task. And once we have the input, we can create the command and execute it. So let's do that there. So we'll do a new start execution command and put in the input, and then we will just you can console log it if you want. I'm just gonna await and send command. Well, those are the changes that we need to do to the function, but as I said before, we also need to edit here. And here, 1 second, what did we call it? So the payment processing ARN. We also need to step functions and comma. Okay, with this we have also the ARN of the state function inside of the resolver Lambda, so it will be able to access it here, and we will send the start command containing the payment ID. In this case it will contain a user. We will have the identity, which will be the sub. So we're expecting that it will add both a new order in the orders table and it will add the order to the user. Then we have a price and the products. So I'm gonna save this. And now that we have that complete, I of course need to change some tests, but I will not be doing this in this video. So after we have done everything, you can deploy this as well. And after it's deployed, let's go and see what we have now and what we can expect. So I went to the website again, where I have my API active and my Amplify Stack. So let's start designing. Oh, of course, we need to log in. So I'm gonna log in first. After I'm logged in, I'm gonna go to design. Then I'm gonna add a picture. And don't mind this, it's still under construction. I'm changing some stuff. But once I press this button, we are expecting that the API will be called with my sub attached to it as identity, and it will return us a payment intender. Once I made the payment, it will continue to the step function, and eventually it will either succeed or fail, and we're expecting it will succeed, and it will add both an entry in our orders table as well as our users table inside of the orders list. So let's continue there. So I am getting the payment intender, that's going good, and I will fill this in, but I will not show it on screen as it's my personal information. And then let's see what happens after I press continue, and I will also successfully proceed with the payment. So let's see what happens. 1 second. So I proceeded with the payment and I was redirected back to my website. And as you can see, the order was completed. The payment was successful. I have a payment intender ID and a client secret. But for now, let's go to our console and see what it actually did with our step function and if it got called. So back in the console, we can see that we have a running state function. If I click on it, you can see that submit task has been initiated and submit has been successfully run. That's why it's green. You can see it here. Success is green. Blue is in progress. So currently we are waiting. And after waiting 2.5 minutes, it will continue for submit job. And then if the job is completed, it will finalize the job. And as I successfully rounded off the payment, it should go to success. So after a second, I will be back once this is done. It takes 2.5 minutes, and then we will see what happened. So after 2.5 minutes, we can see that all the tasks are green now, so they are all successful. And let's have a quick look at what we got as the input. So this is the input. We get some product, which contains one product, and it contains the identity, which is the sub, and user is true. So we are expecting that it was gonna eventually add something to the users table and the orders table. And all tasks are green. I won't go through all of it because it does contain some of my details. But as you can see, that the job was a successful state, and then it did finalize. So let's go to the DynamoDB tables and see if we have entries there that are similar to what we have here. So now I'm gonna go to DynamoDB. So in DynamoDB, we have 3 tables. We have the orders table, stock table, and the users table. And I'm expecting that an entry is created inside of the orders table, and the order was also appended in the users table. So first I'm gonna go into the orders table, gonna check there, and I do see that we have 3 orders. I had 2 successful runs before, so the third one is the one that was just created. You can also see the order date. So we did get successfully an order in the orders table, and it also contains the product, as we can see here. And let's see if also the order was appended to the user. And here we can see that we do have the user with the email, and we have an order there inside of the empty orders object. So both the user and both the orders table have gotten an entry. So it looks like that the state function was successful. And with that, this tutorial is at the end. And in the next video, we will be implementing the IAM functionality to have the anonymous users also be able to make purchases, so that you don't need only Cognito authenticated users. And we will also add the storage part where we will be uploading our images from the website to S3. If you made it this far into the video, consider to like and subscribe for more content like this. Thank you very much, and until the next time.